Okay, we just talked about polynomials, and now we're going to add a little bit more about graphing and then talk about the intermediate value theorem. So if p of x is a polynomial function, so we've already figured out what polynomials look like, the graph of the function has at most n. Remember what n is the degree, the highest power, highest exponent, has n real zeros, and thus at most n x-intercepts, because remember that's what our zeros are, and at most n minus 1 turning point, where a turning point is just where the function is changing from decreasing to increasing or increasing to decreasing. So what we do to graph these is we use the leading term test, which we talked about in the last section. We find the zeros, these x-intercepts, good to even find a y-intercept, and look at any additional function values given. We can look at turning point, and to be able to sketch very quickly one of these graphs. So if we were asked to graph this function, the first thing I remember is on the leading term negative and my exponent is even, that it's going to look like this. We're not sure here in the middle what's going on. Now we find the zeros, which I simply factored out a negative x cubed. So I'm left with 2x minus 3. So when negative x cubed equals 0 or 2x minus 3 equals 0, that's going to give me my zeros, which I can then get my x-intercept. Okay, so remember my x-intercept is when y equals 0. And these zeros will divide the x-axis into these four intervals. And you can just simply choose some values within these intervals. So I'm just simply plugging these back into the original function to be able to see, plot some points to see, in this case, if I'm below the x-axis, if I'm above the x-axis, to be able to graph this. We did just happen to find our y-intercept, but if we didn't, then we could simply find the actual y-intercept. And then, of course, we can look at turning points. It's definitely, looking at our degree. Remember 4, so at the most it could have 4 intercepts, but as we found, it only had 2 intercepts. The multiplicities, remember this was my, let me go back here, this piece right here, multiplicity of 3, multiplicity of 1, which is talking about here, my multiplicities. So since they're odd, the graph crosses the x-axis at 0 and at 3/2, and the end behavior is what we showed earlier. So it's just a quick way to at least have an idea what the graph looks like. We knew overall with what the end behavior looked like. Now we could just quickly find these intercepts and then plot a couple of points to see what's happening with the function. The intermediate value theorem is pretty obvious once you understand what it means. It's just saying if you find a value of your polynomial between 2 points and the sign changes of your function, then apparently it had to have crossed the x-axis. Right? Because if you had a positive value and then it went negative, then somewhere it had to cross. So if you're asked, to determine whether the function has a real 0, so does this function between -4 and -2 cross the x-axis? Well, what you do, if you don't just graph it, you simply plug these values into your function, the -4 and -2. Notice this value of the function, -24, and then then it went positive. So it had to go from negative to positive, somehow crossing the actual x-axis.